Welcome to the Professor's DuBois channel. This is Professor Corey, and this is a mini lecture covering material from our first lecture on Chapter 13. Chapter 13 focuses on chemical mixtures and solutions. So first off, a solution is a homogeneous mixture of two or more substances, and this means it's the same throughout. So if we have a solution, it's homogeneous. So another couple vocab words we need to know here are solvent and solute. So a solution is made up of a solute dissolved in a solvent. And by convention, usually the one that's in the greater quantity is identified as the solvent. And for us, it's primarily going to be water. So we're going to make a lot of solutions in water. Water will be the solvent in most cases. A little more vocab, we can have a saturated solution, and this means, let's say for instance, I'm trying to dissolve some salt in water, and there's a point at which no more salt will dissolve, and we can say that that solution is saturated. If it's unsaturated, what it means is that I can dissolve more salt in the water, and there is this kind of unique, not all that common, supersaturated solution, and the supersaturated solution actually contains more than it should. And the way we do this is we heat up the solvent when we're adding the solute, and we can, at higher temperature, we can oftentimes get more of a solute dissolved. And then if we cool it really, really carefully, there's certain salts that'll be supersaturated, and they're pretty neat because if they're disrupted in any way, like even a piece of dust sometimes falls into this solution, it'll just crash out. All that excess will just come out of solution all at once, and it's quite spectacular. So one of the things about solutions is we really don't know how much. We need a way of knowing how much solute is in the solution, and these are concentrations. So we're going to focus on different concentration units, and these are going to tell us how concentrated or how dilute a solution is. So we'll start off with molarity. We should be familiar with molarity. The molarity is the capital M, and this is moles of solute over liters of solution. So it's the entire solution, that's the solvent and the solute in the denominator, moles of solute in the numerator. And I actually prefer to write my units as moles over liter whenever I have something with the big M, with the molarity. I like to write moles per liter. Next up is molality, and molality is a lowercase m, and it's often like italicized, and this one's pretty unique. And so it's moles of solute, just like molarity, but now it's kilograms of solvent. And this is one of I think it's the only concentration, certainly the only concentration unit we're going to use where the denominator is only the solvent. So moles of solute over kilograms solvent. Next up is mole fraction. So this is a fraction, and it's based on moles. So again, we're going to have moles of the solute in the numerator and total moles in the solution in the denominator, and it's just that fraction. We typically divide the fraction and get a decimal for the mole fraction. When we do mole fraction, we have a solute and a solvent, and if we add the two mole fractions together, they'll add up to 1. So if we had 3 species, maybe 2 solutes and a solvent, and we added up the mole fractions, they would add up to 1. Weight percent, sometimes called mass percent. This is mass, and we get a percent by multiplying by 100. So simply the mass of the solute over the total mass of the solution. So we're seeing a repeating trend here. It's typically solute over solution. In this case, it's a percent, so we have to multiply by 100. Parts per million is pretty similar. We've got, it can be mass-based, mass of solute over mass of solution times a million, but oftentimes we can use this, and for me it's much easier. in a milligram per liter form if we're talking about water, and that's because the density of water is 1 gram per mil. So it's really like milligrams of solute per kilograms of solution. But with water and the density being 1, we can just say milligram per liter. I think that's a very handy way to get at parts per million is using milligrams per liter. Next up is parts per billion, and again, we could do the masses if we had the mass of the solute and the total mass of the solution times a billion, or we could do microgram per liter if it's water. So if it's not water, we could do microgram per kilogram, but most of the time we're in water, so just microgram per liter. You may want to refresh your memory on the microgram, these conversions, going from milligrams or micrograms from grams. So here's a problem. We've got 62.1 grams ethylene glycol dissolved in 250 grams of water. So we can calculate the mole fraction. And so mole fraction, remember, is just the moles divided by moles of solute over moles of solution, and then times 100. So our solute is the ethylene glycol. We take the mass, use the molar mass to get the number of moles, and then we can get the moles of the water as well, same process. So we're going to have 1 mole of the ethylene glycol over 14.9 moles total solution, and we could divide that to get an answer. And there we have it, 0.0671. So that's the mole fraction of the ethylene glycol. If I wanted the mole fraction of the water, I could simply take 1 minus 0.0671, or I could just put the moles of water in the numerator divided by the total moles. So that would be 13.9 divided by 14.9 to get that result. Molality. So this is the lowercase m, and it's often italicized. Now remember, this is moles of solute over kilograms of solvent. This is the odd one. So here again, we're taking the grams we're given using the molar mass to get the moles, and then we're going to divide by kilograms of the solvent, and that was given to us in grams, so we have to convert from grams to kilograms. So units, we could put little m italicized, or we could write the units as moles per kilogram. Lastly, we're going to do a weight percent. So weight, just like the name implies, we're going to use the masses, grams, and so we're going to do grams of the solute over total grams of solution, and because it's a percent, we'll multiply by 100. So we've got the 62.1 grams in the numerator, the sum of both the solute and the solvent in the denominator, multiplied by 100, and we get 19.9%. And I should note here that, if we have two components and 19.9% is the ethylene glycol, if we were asked, well, what's the percent of the water, we could do 100 minus 19.9, or we could put the mass of the water in the numerator over the mass of the solution times 100 to get at that answer. So these are just, a couple examples how to do these calculations. I think I highly recommend using index cards and making some flashcards and getting familiar with the names and what those names mean, because if you're going to get problems where they say you've got a solution and they give you the molality, and if it's just a lowercase m and you don't know what that really means, you're going to be stuck. So get familiar with the units for each of these: molarity, moles per liter of solution, and so that you can quickly rewrite these with their units to solve the more difficult problems. I'm going to try to put together some examples of more difficult problems in a separate video, just to give you some guidance on how to approach those. So again, I hope this was useful. Stay tuned. There's more to come with the Professor's DuBois channel.